Hello guys, welcome to another video. This one is paper 1-1 of May-June 2019 of AdMath. So let's move on to question number 1. So on the Venn diagram below, shade the region indicated. So for the first one, it is A intersection B. So A intersection B will be this one, union C. So it will be this and C. That's for part 1. For part 2, we have A prime, which is outside of A, union B, okay, it's still outside of A, and then intersection C. So it needs to be union B will be outside, intersection C. So C, this one, but not A. So that will be your answer for part 2. Now for part B, on the Venn diagram below, draw the set P, Q, R such that P is inside of R, Q is also inside of R. So we have this set R, big one. P is inside of R, so P is here. Now Q is also inside of R, but P and Q does not touch. That will be your answer for part B. So that is for question number 1. Let's go on to question number 2. So write down the amplitude of this function. So as you know, whenever you have a trigonometric function, it's always in the form of A. This one is sine bx plus c. This one is the amplitude, which is 4. Period is, we use this to find the period, t equal to 360 divided by b. So here b is equal to 3, so that will be 120. Period is 120 degrees. Now for part 3, on the axis below, sketch the graph of this from minus 90 to 90. So pretty easy. The first thing you can do is to draw this line. This is C, which is the baseline, equal to minus 1. So first draw the line y equal to minus 1. The line will be here. Y equal to minus 1. That's the baseline. And then you can see that the amplitude is 4. It means that from this line, it goes up by 4. So 1, 2, 3, and 4. It goes down by 4. So 1, 2, 3, and 4. Okay. So this line, let's draw this line as well as like that. So this will be an indication of where your curve should be in between. So you will never go above this line or below the other line. Okay, so this is just indication. It is not your actual curve. Okay, that's for now. Leave it like this. And for the rest, we can just use the curve. The curve is y for sine of 3x minus 1. So we have x here. It is minus 90, minus 60, minus 30, 0, 30, 60, and 90. Find the corresponding value of y. So you can just use your calculator for that. So for the first one will be 4 sine 3 times minus 90. Sorry. So 4 sine 3 times minus 90 times minus 90 minus 1, that should be 3. Then we have minus 60. So 4 sine 3 times minus 60 minus 1, that should be minus 1. Then we have minus 30. So 4 sine. So yeah, same steps until you have this one is 0, so that will be minus 1. And then 30 again, I think it's the same, so it will be a cycle, but let's have a try. 4 sine 90 minus 1, that will be 3, minus 1, minus 1. Should be a cycle. So now let's draw the curve. Let's plot the points. The first point is minus 93, so minus 93 will be here. Then we have minus 60 minus 1 should be here. Then we have minus 30 minus 5 right here. 0 minus 1 here. 33. Then we have 60 minus 1. 5 minus, sorry, this one is this. Now we just have to join them together to form the other curve. So this one is you have to try your best to make it a smooth curve. Okay, not the best, but yeah, you got the idea of how to do this. So it should be like this and like this. So this will be your curve. Okay, that will be question number 2. Now number 3, the polynomial p of x is equal to this function where k is a constant. So for part 1, write down the value of p of minus k. It means that we have to replace the value of x by minus k. So let's do that. So p of minus k is equal to 2 times minus k minus 1 and minus k plus k minus 12. This becomes 0. So anything times 0 is 0. So your answer will be minus 12. That is part 1. Now part 2. When p of x is divided by x plus 3, the remainder is this. So it means that if p will be minus 3, you will have 23. That's what it means. So we have to find the value of k. So pretty easy. Let's first replace the value of x by minus 3. So p of minus 3 will be 2 times minus 3 plus, minus 1, and that will be minus 3 plus k equal minus 12 equal to 23. So simplify. Minus 2 times minus 3 will be minus 6, minus 1 minus 7, and here we have minus 3 plus k equal to, so 23 plus 12 will be 35. Now minus 3 plus k will be 35 divided by minus 7, that will be minus 5. So k will be minus 5 plus 3, which is minus 2. So k will be minus 2 for part 2. Now part 3, moving on to part 3 of question number 3. So we have to show that p of x equal to minus 25 has no real roots. So let's first, so what is p of x? So we know it is 2x minus 1, k is minus 2, minus 12, and equal to 25. So let's simplify this. We have 2x squared minus 4x minus x plus 2 minus 12 plus 25 equal to 0. So simplify. We have 2x squared minus 5x. That would give me so 5x here, that will be 10 minus 15 equal to 0. So a is equal to 2, b equal to minus 5, and c equal to minus 15. So how do you prove that it has no real roots? So we have to find the value of b squared minus 4ac. So b squared is 25 minus 4c will be this. So this will be equal to what? 25 minus 4 times 2 times minus 15. That will be, let's try this, 25 minus, oh, it's plus. Oh, here's plus, right? So I almost made a mistake here, so let's correct that. 25 minus 4 times 2 times 15. That should be minus 95, which is less than 0. So by proving this, this proves that px equal to minus 25 has no real roots. So that is question number 3. Question number 4, part 1. The first 3 terms in ascending powers of x in this expansion can be written as this. So find the value of a, b, and c. So we have to find the first 3 terms of this. So let's expand. 2 plus bx, 8. That will be 8c0, 2, 8, and bx0. That's the first term. Second term, 1, that will be 2, 7, bx1. And third term, that will be 2, 6, bx2. So now let's simplify. This is 1. So we can just use our calculator. So 8c0 is 1 times, so 2 power 8, this is 1, plus 8 choose 1 is 8, 2 power 7 times bx, and then 8 choose 2, 8 choose 2 is 28, 28, 2 power 6, b squared times x squared. So now we have to compare to a plus 256x plus cx squared. So this is a, so a is equal to 2 power 8, which is equal to what? So 2 power 8 is 256. Now for b, so we have 8 times 2 power 7b equal to 256. So b equal to, so 2 power 7 times 8, 256 divided by, that will be 1 over 4. That's the value of b. Now for the value of c, c equal to 28 times 2 power 6 times b square. So let's do that. 28 times 2 power 6 times 1 over 4 square. That will be 112. So the value of a, b, and c is this. I hope that was easy. So we just have to expand and find the corresponding values. Now for part 3, using the values found in part 1, find the term independent of x in the expansion of this. So let's use the first 3 terms as well. So in this expansion, the first 3 terms that we have was a is 256 plus 256x plus 112x squared. So what is the expansion of this one? So pretty easy. That will be 4x squared minus 2 times 2x times 3 over x plus 9 over x squared. Okay, so now let's expand and find the term. So let's simplify this as well. This will become, so now we have 256 plus 256x plus 112x squared multiplied by 4x squared. That will be 2 times 2 times 3. That will be minus 12 plus 9 over x squared. So we have to find the term which is independent of x. So the term which has no x in it. So we have to expand this with this. So which term has no x in it? So as you can see, if you multiply this by this, you will not have an x. So let's do that. 256 times minus 12. That's the first part. Now let's see what else do we have. So this one has an x. So this one, if you multiply this with this, you will not have an x. So plus 112 x squared multiplied by 9 over x squared. So x squared goes away. So what is your answer here? It will be 256 times minus 12 plus 112 times 9. That should give me minus 2064. That should be my answer for the term which is independent of x. That will be question number 4. Question number 5, a particle P is moving with a velocity of 20 meters per second in the same direction as this. So part 1, find the velocity vector of P. So pretty easy, you have to do 20, the value of the velocity, times the unit vector in this direction. That will be 3, 4 divided by magnitude of this will be 3 square plus 4 square. That will be 20 times 3, 4 divided by, this is 9 plus 16, 25, 5. That will be 4. So the vector will be 12, 16. Okay, that is part 1. Let's call this VP equal to 12, 16. Now part 2, at time t equal to 0, P has position vector of 2. So that is the initial position of vector of P. Now write down the position vector of P after t seconds. So at first it is here. So let's call this position vector. So at first it is at this point at t equal to 0. Now after t seconds it will be t times the speed, which is this. I hope that makes sense. This will be your answer here. And for this one, a particle Q has position vector this. So let's say V, Q, that should be. At first it's 17, 18. And now he has velocity vector of this. So its position after t seconds will be this. So we have this and this. Now question part 3. Given that P and Q collide, find the value of t when they collide and the position vector of the point of collision. So we have to find the value of t when they are both in the same position. So basically we have to equate this plus this equal to the same position as this vector. So position of Q equal to position of P at time equal to t seconds. So simplify. Here we have 17 plus 8t equal to 1 plus 12t. So let's solve this. We have 4t equal to 16, so t equal to 4. So basically they meet after 4 seconds. So now what is the vector position? So position, just replace t in any of those. So let's do that. So here we have 1 plus 4 times, so 48 will be 49. And here we have t times 16, so 4, 64 plus 2, 68. So that's the position vector for when they meet. So we have this as your first answer and this as your second answer here. So that will be question number 5. Question number 6. So here we have a curve and a line. They meet at point P and Q. So we have to find the area of the region. So it is this region. So how do you find this area? You have to first find area under the line minus area under the curve. So we first have to find the x-coordinate of P and the x-coordinate of Q. So we have to find where they meet. So let's solve this simultaneously. So y, 2x plus 5 equal to 3x squared minus 2x minus plus 1. Simplify. Minus 4, and this one becomes so minus 4 as well. So simplify, we have this 3x squared is 3x times x, 4 is we have 1 times 4 or 2 times 2. For us to have minus 4, we can have 2 here and 2 here, minus 6 plus 2. So value of x will be minus 2 over 3, or x can be 2. So it means that the value of x here will be minus 2 over 3, and here is 2. So now let's find the value of this region. So how do you find the area again? It will be A. It will be from this limit from 2 and minus 2 over 3. It will be area under line. So the line is 2x plus 5 minus area under curve, which is 3x squared minus 2x plus 1 dx. So let's simplify this and see what we have. So this is the same, and we have 2x plus 5 minus 3x squared plus 2x minus 1 dx. So simplify, becomes minus 3x squared plus 4x. So that will be 4x and then plus 4 dx. So let's solve that. So it becomes minus 3x squared or x cubed divided by 3 plus 4x squared divided by 2 and plus 4x. That will be between 2 and minus 2 over 3. So simplify, here we have, this goes away, we have minus x3 plus 2x squared plus 4x, 4, 2, and minus 2 over 3. So simplify, this will become minus 8 plus 8 plus 8 for the first one. And here we have minus 8 over 27 plus 8 over 9 and minus 8 over 3. So here this goes away. We will have 8 minus. So what is the value of that? So here I did make a little mistake. So this is not the correct value here. This should not be okay. So the mistake here I made was when I put this value in this, it should become plus. So plus this plus that. So let's do it again. 8 minus. So that will be 8 over 27 plus 8 over 9 minus 8 over 3. That will be this. So 8 minus answer. That should give me. So your answer should be 913 over 27, which is 9.48 units squared. So this will be your answer. So here the only mistake I made was when I put this into this, it needs to be plus and not minus. So 8 over 27 plus 8 over 9 plus, so minus 8 over 3. That should be minus 113 over 27. That should give me this value. That will be question number 6. Question number 7, part A. Solve this equation. So we can see that the base here is different. So how do we convert log 9x to log 3x? So we have to separate those two. Log 3x be log 3 of 9. So this here will be 2. So replace, we have log 3x plus log 3x over 2 equal to 12. So times 2 everywhere, we have 2 log 3x plus log 3x equal to 24. So add, we get 3 log 3x equal to 24. So log 3x equal to 8. So x becomes 3 power 8. That will be what? 3 power 8 will be 6561. That will be your answer for part A. Now for part B, solve this equation. So we can first send log on this side. We have log base 4 minus 10 minus, so 2 we can send 2 on top. We have log 4y minus 1 square equal to half. Now simplify, we have log base 4. This will be 3y square minus 10. Minus will be divided by y, this equal to half. So we can send this one over here. We will have, so this is the same, and this will become 4 power half. This is 2. So we cross multiply, we have 3y square minus 10 becomes 2y minus 1 square. So let's expand the brackets here. Here comes 2y square minus 2y plus 1, which is 2y square minus 4y plus 2. Now simplify, we have, so 3y square minus, that will be y square, minus 10, so this becomes plus 4y, and we have minus 10 minus 2, minus 12, becomes 0. So here we have a few options. So we have 12 is 1 times 12, 2 times 6, and 3 times 4. So for us to get plus 4, we have only one choice, 6 and 2. So it's plus 6 minus 2. So y equal to 2, y equal to minus 6. So these will be the two options for your answer. That will be question number 7. Question number 8, it is given that f of x equal to 5 exponential of x minus 1. Now x is defined for everywhere, which means x is defined for minus infinity to infinity. I hope that makes sense. Now write down the range of f. The range is the y values. Where does it go? So let's have a look. This is x, this is y. So this is minus infinity, and this is infinity over here. So let's replace infinity in this value here. So if x is equal to minus infinity, for example, let's say it is equal to 5 exponential minus infinity, that can be minus 99999. For example, that will give me 0. 0 minus 1 will be minus 1. So the minimum value of y will be on this line, y equal to minus 1. So as you go here, it approaches the line minus 1. And then you touch it afterwards. So that will be my curve here. Now when x goes to infinity, let's say for example 5 alpha power of 9999. So as you can see, it keeps going, right? So it is, so let's say so for example, if you increase the value of x, it will keep going up. I hope that can make sense. So let's find if it passes through here or not. So if x equal to 0, we have 5 4, so 4 will be here. So basically the graph may have this shape. So here it approaches the line minus 1, and then it will go up, up, and up. So it means that the range of f is equal to y is bigger than minus 1. I hope that makes sense, because if you go to minus infinity, it approaches the line minus 1. It never touches the line, it only approaches this line, and as x increases on this side, it keeps going up. So the range is the y values, so it keeps going up, so this will be your range. Now for part 2, find f inverse. So first step is always let y equal to 5 ex minus 1. Now we have to make x the subject of formula. So 5ex equal to y plus 1, ex equal to 1 over 5, y plus 1, and so x will be ln 1 over 5 plus 1. This will be the value for f inverse. So f inverse will be in terms of x. That will be ln 1/5 plus x plus 1. That will be f inverse. Now state is domain. So you have to know this trick. Domain of f inverse is actually range of f. So let's write this down. Domain of f inverse is equal to range of f. So now the same way, say range of f inverse is equal to domain of f. So using this technique, you have to write down domain of this equal to range. So basically x is bigger than minus 1 for the domain. This will be part 2. Now part 3, it is given that g of x equal to this function. Part 1, find f of g of x. So what is f of x again? It is given to us as 5ex minus 1. So let's replace the value. Let's find this first. Let's find fg of x. So let's find that. So 5ex will be x squared plus 4 minus 1. Now fg of 1. So it will be 1 plus 5 minus 1. So this will be your answer. So you can also find the value. 5 minus 1. That should give you, or you can write 741.065. But this is the exact value if you want that value here. Now to part 4, find the exact value of this. So first we have to find this. So we know that g of x is equal to x squared plus 4. So one thing we can have, so this happens almost all the time. So when we think about g squared of x, we think about gx squared, but it is not the case. So g squared of x is actually equal to g of gx. So let's do that. We will have g of gx will be x plus 4 square plus 4. That's the value of this. That will be equal to 40. So let's simplify. We have x power 4 plus 8x squared plus 16 plus 4 equal to 40. That will be x4 plus 8x squared plus 20 minus 40 minus 20. So now what can we do is we can replace this. So let's say that's okay, let's leave it like that so we can find the values. That will be x squared times x squared, and then 20 is what? 20 we can have 2 times 10, 1 times 20, or 4 times 5. So for us to get plus 8, we have to use this. So we have to use 10 and 2. So that'll be plus 10 minus 2. So x squared is equal to 2. So x is plus minus square root of 2. And this will be minus 10 plus minus this. So this is imaginary roots. So we can find those values. So this will be the two values of x. X will be plus minus square root of 2. This will be your answer for question number 8. Question number 9. In this question, all lengths are in centimeters. A closed cylinder has a shape like that. I hope you guys know this already. It is closed, so closed. Has a base or radius. The radius is r, and the height is h, and the volume is v. It is given that the total surface area of the cylinder is this much, and v can vary. Show that v, which is the volume, equal to this. So we have to use the total surface area given to us. So area is 600 pi. So how do you find the area of this shape? We have area of curved surface, and we have top and bottom area of circles. So that will be circle is pi r square, so 2 top and bottom, plus surface area will be curved surface 2 pi r h, will be equal to 600 pi. So we can simplify. Pi goes away, divide by 2, that will be 300. So we have r square plus r h equal to 300. So from this we have h equal to 300 minus r square over r. So let's keep this for now and find the volume. How do you find the volume of a cylinder? So we use the formula pi r square h. So pi r square h is 300 minus r square over r. So let's simplify. So first one we have 300 pi r square minus pi r square power 4. Sorry, power 4. That will be divided by r. So you simplify, you will have 300 pi r minus pi r cube. That will be your volume, same as here, shown as required. Now for part 2, find the stationary value of v, determine its nature. So you would say at stationary value dv by dr equal to 0. So let's find dv by dr. So dv by dr is 300 pi minus 3 pi r square equal to 0. So let's send this one over here. We have 3 pi r square equal to 300 pi. So pi, that will be 100. So r square is 100. R is equal to square root of 100, which is 10. 10 will be the value of r. So what is the value of v? So we have to replace r in the equation. So v is 300 pi r minus pi r cube. So for r equal to 10, v will be 3000 pi minus 1000 pi That will be 2000 pi. That will be the stationary value of v given by this. Now determine its nature. So to find nature is very easy. We just have to find the value of this 2 at r equal to 10. So let's do that. Let's find this. This will be 0 minus 6 pi r. We place r in this, we'll have minus 60 pi, which is less than 0. So if it is less than 0, it means that v is a maximum value. So stationary value of v is a maximum value. So that will be question number 9. Question number 10, we have when log y is plotted against x squared, a straight line graph is obtained. So we know that straight line is equal to mx plus c when y is against x. So here we have log y against x squared, and if you have a straight line from this, you will have log y equal to mx squared plus c. So it's the same, m is still the gradient, we can find that, and we can find the value of c. So let's use these 2 points to find the value of m. So m is equal to y2 minus y1 over x2 minus x1. So y2 will be 16 minus 4 divided by 6 minus 2. That will be 12 divided by 4. That will be 3. Now replace in the equation we have log y equal to 3x squared plus c. Now let's find the value of c by using one of the points. This will be x squared, this will be log y. So 4 equal to 3 times 2 plus c, c equal to minus 2. So from this we have log y equal to 3x squared minus 2. So now you want to express this in the terms of this. So very easy. Y will be log 10 power 3x squared minus 2. So in this form exactly, we will have y equal to 10 minus 2 plus 3x squared. That will be your answer for part 1. Now for part 2, it says find the value of y when x equal to this. So y equal to 10 power 3x squared minus 2. That should be 10 power. Simplify, this becomes 1 over 3. The 1 minus 1 becomes 1 over 10, which is 0.1. That will be part 2. Now part 3, find the positive value of x when y equal to 2. So y is 2. 2 here. That will be minus 2 plus 3x squared. That will be log 2 equal to 3x squared minus 2. So 3x squared is equal to log of 2 plus 2. X squared is 1 over 3 log 2 plus 2. Now x is square root of this one. So you can simplify to find the value, or you can leave it as such, that's okay as well. So let's simplify. We have log 2 plus 2 times 1 over 3 square root. That will be 0.876. This or this. So that will be question number 10. Question number 11. It is given that y equal to this. Show that dy by dx equal to this, where p and q are integers. So let's solve. So let's find dy by dx. So first one remain the same. Then differentiate this one, we'll have half. 2x minus 3. Half minus 1 will be minus half times. Inside will be 2. Now plus. Now this one remain the same. And now we differentiate this one, we get 2x. So simplify, see what do we have. So 2 goes away. And here we have what? Here we have x over 2 plus 1. this will becomes square root of 2x minus 3 plus square root of 2x minus 3. This will become 2x over 1. So let's find the LCM. So we have this plus 2x minus 3 over minus 3. So what do we have here? So let's expand. This becomes 4x squared minus 6x divided by this. So simplify, we have 5x squared minus 6x plus 1 over. So this is the same as this. So now we compare this with this. So P is 5 and Q is minus 6, and this is the base. So shown as required. So now for part 2 of question 11. So hence find the equation of the normal to the curve at the point where x equal to 2. So what is the value of y when x equal to 2? It will be, this is 5 times 1, so 5. So y will be 5, so the point will be 2, 5 at where the normal passes through. So now if you want to find the equation of normal, so you first have to find the gradient of normal. So if you want to know the gradient of the normal, you have to first find the gradient of the tangent at x equal to 2. So we know from part 1, dy by dx is equal to what? 5x squared minus 6x plus 1 divided by square root of 2x minus 3. So let's find dy by dx at x equal to 2 at this point, right? So replace, we have 20 minus 12 plus 1 over square root of 1. This will be, so let's find that. This is 9. So gradient of tangent is 9. So from this we know that gradient of normal will be minus 1 over 9. So if you have the gradient, you have the point, which is 2, 5. You can find the equation of the normal. So y minus 5 divided by x minus 2 be minus 1 over 9. So now we cross multiply, we have 9y minus 45 to minus x plus 2. So now we have to bring x on one side. How becomes x plus 9y minus 47. So your answer is in this form, which is ax plus by plus c equal to 0. So this is your answer for equation of normal. So that was the last question of this paper. I hope that was helpful, and thank you for watching.